Okay, this is part 2 of lesson 3. Okay, in this video, I'm going to show you 90 degrees plus theta. Previously, we did 90 degrees minus theta, which falls in the first quadrant. Okay, this reduction formula falls in the second quadrant. Do you see, guys? So it's 90 degrees all the way to the 90 degrees plus the theta angle. Okay. So you can see it falls in this quadrant, and I'll keep in mind which one of sine, cosine, tan is positive here, and because that will have an effect. Okay, so let's see over here. These two angles are exactly the same. They give us the same answer. Sine of 120 degrees equals, those two are the same, okay, equals exactly the same as cos of 30 degrees. Now, do you see that 120 minus 30 gives us 90? So that gives us a clue that you can use a reduction formula here because they give you the same answer. Okay, so if those two are the same, then sine 120 equals cos 30. Okay, now this is what you're going to do. You're going to take the 120, okay, and you say 90 plus 30. There is our reduction formula. Can you see? We're not going to use that one, guys, because that is less than 90 degrees. And we're working here with this one. So 90 plus 30 is 120. So that is the same. Okay? And if that and that is the same, then that will also be equal to cos 30 degrees. Okay. And do you see there's a 30 degrees and there's 30. Okay. Let's look at this one. Cos of 110 degrees is that. Okay. Negative 0.34. And sine of 20 degrees is the same, but it's a positive answer. Okay. First, let's look at our clue. Do you see 120 or no, 110? Negative or minus 20 equals 90. Okay, so that indicates to us that we can have the same answer. But why is the one negative and the one positive? But over here, they were both positive. Okay, it's because, okay, remember guys, this one falls in the first quadrant. Okay, and all of them are positive here. But in the second quadrant, okay, because these fall in the second quadrant. In the second one, only sine is positive and the rest is negative. So sine is positive and that is why cos is negative. That is what I wrote there for you. Okay, so if we take this and do this with that, do exactly the same, we can say that cos 110, so we take the bigger angle, is the same as, now we're going to use our reduction formula, we're going to do something with 90 degrees, okay, plus 20 degrees, that and that is the same. So, do you see that that equals sine negative? Why? Because they ask cos, and cos is negative in the second quadrant. Okay, if you don't understand yet, look at this. Sine 90 degrees plus theta, second quadrant. Cos CAS. So sine is positive. So that will be exactly the same as cos of theta. Okay. But cos of 90 degrees plus theta will be negative sine of theta. Why? Because cos is negative here. And you're not going to look at your answer, okay? You look at what they ask. This is cos, so you must have a negative answer, and it will be the same as sine of theta. Okay, so important, 90 degrees plus theta is quadrant 2, so keep in mind that in quadrant 2, sine is positive and cos is negative. Okay, and again, just as in the previous reduction formula, the previous video, sine will change to cos and cos will change to sine in this this one, you just have to keep in mind your signs, negative, or whether it will be negative or positive. So this is the same as cos theta, and cos 90 degrees plus theta is the same as negative sine theta. Okay, so let's apply that. Simplify the following. Sine 180 degrees minus theta over cos 90 degrees plus theta. Okay, now I remember from my previous videos and previous reduction formulas that is the same as sine theta. Okay, go to the previous videos and go have a look. Okay, and this one also falls in the second quadrant. So sine is positive. Now, cos of 90 degrees plus theta is the same as negative sine theta. Here we looked at that. You see, because this angle falls in the second quadrant and cos in the second quadrant will give us a negative answer, but the same as sine theta. Okay. So, and over here, we cannot cancel anything out. We need to get a sin at the bottom or a cos at the top. So you need to change them by using reduction formulas, and that's exactly what I did. So now these two cancel, and I'm left with minus 1. Okay. Guys, if you struggle with the work, I know it's confusing and it's not that simple. There's a lot of other videos and more videos on YouTube as well. Maybe you find someone or a video that explains it a little bit better than me. Remember, I'm still a little bit inexperienced with explaining the work. So please go have a look at more videos, go through the examples in your textbook as well, and read through that, and then I'll send you the homework. Good luck.